on this. Hello. So welcome today. Today, what we are going to read is the random forest. So, what is a random forest? Basically, that we will look into that one. So, in our day-to-day activities, what we do is we say we are going to some office or some place. So first thing we do is let me share myself. Okay. The first thing we do is we get up in the morning, we brush our teeth, we do all the we get ready, we eat breakfast, we go to bus, train, and then go like that. So there is this type of sequence where you eat breakfast after you take bath or after you get ready. You get ready after you wake up. So wake up, get ready, eat breakfast, go to car, go to bus, go to train. These all form a sequence. Okay. In this sequence is called Brownian motion. That means a particular event happens after a particular event. So this is called Brownian motion. So in our context, there are two things. One is classification and regression, right? So in classification, we are saying we are categorizing. We are having some categories. So for example, weekday is between Monday to Sunday, right? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So these are 7 categories. Okay. And for example, if you say, okay, shopping, right? Shopping has a specific set of categories that you do on a regular basis. So for example, if you're going for a weekly shopping, you do milk, coffee, powder, soap, shampoo. Soap and shampoo you do monthly once, but weekly like vegetables and any other like chocolates and all those things, cookies or chips and all those snacks, cookies, milk, vegetables, all these things we do on a regular basis, right? So if we are to categorize, if we have to say, hey, will a particular person do shopping in Saturday, or will they do on Friday? Will they do on Monday? Or when a person does shopping, what are the regular things they buy on regular basis? Like those kind of things need categorization of things. So this is called multivariate classification. Single variate classification means, is a person going to shopping, yes or no, right? So that is where you have binary thing, where yes or no kind of scenarios, you call them as single variate. But in multivariate classification, say the same thing like groceries. Will person buy vegetables? What vegetables are the person is going to buy? Tomato. Someone you will be very surprised that your purchase of vegetables, the category of vegetables you buy, will always remain same. You check it out. You go to the same
shop.
You go to the same gas station. You shop the same vegetables every week.
Correct.
Okay. So you will have some variation here or there, but most of the time you'll buy the same vegetables. So a multivariate classification could say you are going, you can set the, say if you are Safeway or Walmart or Costco or any other company, then you're buying vegetables, right? So in that case, you want to know how many people, not just how many people, you want to know what kind of vegetables are fast moving, what kind of vegetables do I need to stock up. So all those things are fall into multivariate classification. So this kind of classification is very common, very useful for for any. And it's more useful for small players than the big players. See, for
I
example,
see.
Costco is there. You can have the set of vegetables, and if someone doesn't buy those vegetables, they can just recycle it, or throw it away. But for a small vegetable vendor, the minimization of waste
It's
is
very important.
minimization of waste will actually make the vegetable vendor more profitable. So
We have a we started one grocery chain back in India.
uh,
So whatever example you are giving, that is making me more relevant. So yeah, go ahead.
yeah. So not only groceries, even a simple kirana general stores, right? So they will have, for every item that they are buying, there is a margin that is being cut on
Correct.
the number of days the item is in the store. So
Mhm.
how do you come up with a algorithm that says, that tries to narrow down how many items you need to buy, and next comes the quantity, but you need to know how
Yeah,
many.
because main point, Sharath, especially in India, the grocery shops have a area space restriction.
Hmm.
So you cannot have unlimited space to keep these things. That is where this whole example makes a lot of sense, because you cannot keep a big chunk of items which are not sold, and then that space may take by another item which is a fast running item, right? So all these statistics needs to be available to the owner so that he will plan the place, because you don't have a infinite space in your shop, so it's limited space. So that is the main key there actually. So
Yeah, and also the profit margin.
profit margin, yes.
So if you keep most of the kirana stores, they keep lot of rice,
Correct.
take a lot of space of rice,
Correct.
and most of them are selling the similar kind of rice most of the time. So instead, if you had, there is a reason why the rice is occupying a lot of space, because when a customer comes in, they see the rice. Rice is something that is a very stable food. Oh, you have rice. Okay, let me take rice. Rice is something that they have to take
That,
any. So
got
you,
you.
a small guy selling rice or a big guy selling rice, the effect is same. Whether it's
Correct.
rice, tomato, carrot, onions, the effect of the purchase, whether you are doing it in small store or big store, is same.
Correct.
So when you have rice is a staple food that everybody has to buy, not even want, they need to buy. So therefore they keep lot of space for the rice. So instead, if they had different varieties of rice, and then they put like Starbucks, right? When you go to Starbucks, you see different varieties of cookies and all those things on a um, uh, glass, but they are only dummies. So you
Correct.
say, I want this, I want that. They go inside and get you the
Correct.
thing. Like that, if a lot of small um, stores depict this kind of different varieties of rice, then they can emulate or simulate what Costco is doing, or what Walmart is doing, what big stores are also doing. In big stores, you see a series of uh, branded rice, and then another series of branded rice. So instead, if you had one, two, three, just copies of that branded rice, then you can simulate whatever is Costco say selling. I'm also selling the same thing. So such kind of innovation, such kind of change adaptability can actually make a lot of profit margin. So
Got
therefore,
it.
this random forest is, if we implement it properly, it will be a very good thing. And also the demographic location. So in one particular area, the people there buy specific set of things, and in another particular area people buy some specific set of things. So like that you can actually fine tune the algorithm for a small guy. So most of
Gotcha.
the AI ML is very helpful to the small guy than a big guy. So the more smaller you are, the more innovation you can do, the more accuracy you can get out of your business um, forecasting. Okay, having said that, so let us
Yeah.
move into the actual theory. So this
Mhm.
is this is random variables. Okay, this is not random. Oh, this is right. Yeah, yeah. So Berkeley has given a very good. I'm highlighting this one, so
Mhm.
it is easy for people to see. Stat.berkeley.edu Brayman random forest. So take a look at this and don't get you know
Carried away with.
don't get afraid that, oh, you have so many this thing. You try to the way to look at mathematical problems is to uh, apply that to your real life scenarios.
Correct.
Then it becomes very easy. For example, this uh, upper bound of generalization error is given by PE star less than or equal to rho 1 minus S square by S square. So this looks very huge thing, but once you start uh, knowing what is
I used to wonder, Prakash, in my high school intermediate days, right? I represented mathematics Olympiad at the state level. And
very nice.
now, yeah, now if I look at all these formula, right, I'm really, really afraid of looking these actually. So,
Yeah, but these are actually trying to, prediction is always a art more than science. So what machine learning is trying to do is coming up with math, coming up with science to do the work of art. That's
yeah.
how you have to think. Say, for example, prediction probability that you are going to eat rice tomorrow
Mm,
varies where you are. For example, if you are in England, you may not eat rice tomorrow.
mm,
If you are
mm,
going to office, you may not eat rice. But if you are
mm.
at home and you
Yes.
are Asian and you are accustomed to eating rice, then the probability is one. So like
Mm,
that, the scenario changes. So probability of eating rice, given that for 5 days in a week the person has eaten rice, is 5/7. There are 7 days in a week, and for 5 days you have eaten rice. So tomorrow, if you want, what is the probability that you are going to eat rice is very high.
correct.
Instead of saying very high, what math is saying is 5/7. So that's how you have to look at it.
Mm,
Okay, so this Berkeley dot, why we need these theories, why we need these papers, theses, PhD theses, is to understand the science behind our prediction.
gotcha.
So these random features are very important to know that, okay, what does random features mean? Random features means you are trying to select something out of the blue with the existing features. So what could a feature be? A feature of vegetables could be a tomato, brinjal, coconut, um, and some beans, all those things. You can make it as a feature. So randomly, if you want random features means, okay, I'm just picking up tomato, brinjal, and coconut, right? So out of 7 or 8 things, you're picking up randomly. That's called random features. That's it. There's not much big about it. So now coming back to our implementation. So what we are going to do, this has been done in Kaggle also. So what we have here is a data about the uh, landscape. So each one is representing, each one is a feature. Okay. All these things are features. And the last value is the category. So I told you the category is basically those that have what do you call outcome, right? So think about that, like you're trying to buy some 7 vegetables, and what is the vegetable you have bought? Or in this
Hmm.
in this scenario, this is talking about whether the field is cultivable or not. So this is
So in this data, sorry, I had a
yeah,
little
yeah,
bit
yeah.
of distraction.
Huh.
So here the numbers like 2609214 in the line 14,
Hmm.
right? Whatever
Uh,
highlighted. So what are those numbers actually? Those are all.
this is the area of the particular. This is like forest in North Carolina,
Okay.
Colorado.
Mm-hmm.
This is the data about forests in Colorado. So each one
Hmm.
of them. And yeah, let me go to the
Yeah.
casual.
How
Uh,
they generated this data, right? How they came up with that?
yes, yes, yes. Let me do that. So this is basically, yeah, curve type. This is called curve type, right? So
Hmm.
if you just do a curve type, then it will give you of machine learning repository what this is consisting of. Curve type info will tell you about what this uh, so let's go. If you go to curve type info, you'll get everything. What is this telling and all those more. So it tells you about the forest type and what each of these things are.
Hmm.
So relevant information, number of instances. This is what are the features.
Hmm.
So there are total 7 features,
Hmm.
7 types that are there.
So first one is code, right?
Ah,
These are all codes actually.
yeah.
2701 is cathedral, family, rot, extremely stony. I think first row is belongs to that, right? 2702.
Let us do like this. Okay, 2504.
It's not there.
This is not,
I don't think both are correlated.
this guy.
Yeah, I think that is the one. Okay.
So this is like
Yeah.
1, 2, 3, 4, 5, 6,
6,
7,
7,
8.
8, 9.
Study code, ELU code, Gothic family. So the ninth, what is this? Soil types.
Hmm.
This is the soil type.
Hmm. These are all soil type. Yeah. All the 40, I think they gave.
1 to 40. 40
Hmm.
varieties are there. So
Hmm.
all these varieties of the soils exist in a
Hmm.
particular Colorado forest.
Hmm.
And geologic zones, alluvium, glacial. These are all the geologic plates that
Hmm.
give out those things. So I mean, it's good. You take a look into this one.
Yeah, yeah, yeah. Sure, sure.
It'll be very this thing.
Yeah, means coming to data, we need to understand all those fields, right? What
Yeah, yeah,
is
yeah. So cover type is a integer. Okay, so let us see where it is doing. Cover type, soil type, soil types. Okay, cover type will be.
so the below is like metadata, right? Description of data.
So the cover types is the last one, whether it is lodgepole, pine, and all those. So basic summary statistics for quantitative variables. What are the meters, azimuth, degrees, and all those things are here. Okay. In class distribution, the curve type, this is basically put in the Kaggle also. So I've just took one thing, and it will also give you neural networks. You can use the same thing for using the neural network and other things. So take a look at this one also if you get some chance. But right now what we are going to do is, based on the data, we are going to find out what kind of the category of soil we are going to get. No, not category of soil. There are only 7 types. Okay, let me just see. Cover type. What kind of cover type we are going to get out of the things? So it is an integer. All other things, there are few. You see here, there are few.
I think soil type 40 binary column, right? I think if you count 0 and 1, they must be 40, I guess. In your data, and also 5 binary column wilderness area, right? 5 binary columns.
40 binary column soil type.
Yeah.
If you look into the soil types, you got this 2702 and 6102 and all those things. So in this you have 1, 2, and 3. Okay, 1, 2. 4703. Let us see what this is.
So if you copy this into Excel, you know each and every column.
Okay.
Then you will know what are the names. Yeah.
So let us take out this guy.
CSV. Yeah. Excel is there.
Excel is there, but this is. I have not installed Excel. This is only.
Oh, it is there.
It's trial version.
Read only, trial version.
Yeah. There is another one.
If your kid is a grown up, then you can take the college edition and all, right? So that's very good.
I have open this thing also. There is a open office that is free. That does everything. Yeah, this way.
Yeah, I think it opened up well. Yeah, trial version is okay as of now. Yeah.
Your trial has expired.
Oh, okay.
1:2596, but hey, let us do it Office Calc. We don't see the headings here. But do we have the headings? We don't have the headings. We don't have the headings. Okay.
Yeah.
So yeah, we have to go through what each of them is and how we are trying to emulate. So each of the here, meters you can put in numbers, whereas degrees is basically not in numbers, even though it is depicted as numbers. And the hillshade is an index, right? He'll say noon, 9 a.m., noon, 3 p.m., horizontal distance to fire points. All these things are very important for a wildfire firefighting thing. Okay, so what I'm trying, what we have is we have multi-layered data. Few of them are integers, few of them are indexes, few of them are degrees, which is not a double. It is a double, but it's not actually a double value. So like that you have. Now we want to know what is this random forest actually is doing. So different kind of data types you want to group and do the prediction. So let us go into little more detail about what a random forest actually is. If you do a simple Google, you'll be able to know. So let's do a simple Google.
Yep.
The best way is images. So if you see here in our classified classification, what this is doing is it is taking the instance and it is creating a random, it is creating 1 tree, 2 trees, 3 trees like this. In this classification, assuming that this is the right, in the right most corner, if we want to say that this is the right ones. So if you take a look, okay, we are going from, we are dividing the whole data into an anchored ones on basis of one value, one random, and then we are doing this. So we are creating a different trees. So where the highlighted ones is the right thing. Say for example, will you take umbrella tomorrow to go? So based on if you see cloud, so tomorrow if it is a sunshine, you don't even take anything. But tomorrow is sunshine.
If it is a shade.
Tomorrow is sunshine. You see sunshine, but you are seeing prediction that it is going to rain. And you look into whether you have to walk something, and then you take the umbrella.
Correct.
So in case, okay, tomorrow is sunshine and there is no prediction, then any of these things is that you don't take an umbrella.
Okay, I don't take it. It doesn't matter actually.
So like that, the data is divided into an anchored route. In our, I told you in the first case itself, the Brownian motion, right? You are getting up early.
I'm able to correlate, Prakash. That's good.
So like that in the Brownian.
Unless you wake up in the morning, then only the following action will happen, right? So yes or no, yes or no, yes or no. Right. So yeah, go ahead.
So in our different, columns, you are taking one column and anchoring it as a root. Okay, and then you are saying you are putting other columns associated with that as a root. A fifth column you take, which is like breakfast has been eaten, yes or no. So if breakfast has been eaten, it already means that I've woken up early, I've done all those things, right? So if it is, say, breakfast has been taken, if it is yes, then I don't need to go through all these things. Okay, so the path, if I don't have to look at all the different data nodes to actually understand that, okay, I am going to office. So I can just say breakfast has been eaten, yes or no, and then I can, based on that, I can assume that the person is going to office or not. So obviously, at times you don't eat breakfast, but still you can go to office, right? So that is where the predictions usually don't. So you will be able to take predictions but all
If
the necessary.
your steps are perfectly followed every time, then the prediction is easy. If any skip is there, then the prediction will become complicated. We don't know what is the next step, right? So,
Right. So that
mm,
kind of things are expected in the algorithm.
mm,
Okay. So any model, algorithmic model, you have to expect that there will be few cases where you are saying the person, where you are saying the event will not happen, but the event will happen. So that's called false negatives. There are false positives and there are false negatives. So for example, I may eat breakfast, but I may not go to office. So but if I say I am based on eating breakfast, this guy has gone to office. I predict like that, then it becomes false positive. So at times, because I didn't eat breakfast, I will not go to office, but I have gone to office. Then it means it's a false negative. So like that, you will have false positives, false negatives, and we'll come into the uh, picture about how to identify them or how to do it. So if you see here, a single decision tree is like this. In a random forest, many of these trees are generated. This is called ensemble. Many trees are being generated. And then in what is classification and what is regression? You have to basic things that you are predicting. Okay, classification means one out of few categories. Multivariate classification is between, say there are 7 categories or 5 categories or 10 categories. Out of all the thousands and thousands of rows that we take, definitely there will be only 10 categories and we are trying to predict them. Then it's a classification, 10 between 0 and 10, for example. So it could be like, will all these 1,000 people go to movies? Then it is a binary thing, 0 or 1. So will all these people go to movies as well as eat in a restaurant? Now movies and restaurant has become 2 categories. So will all these people go to movie, eat in a restaurant, and will choose some local vendor or restaurant by the street food? Now street food vendor, restaurant, movie, like that the category has changed. So this is called multivariate categories, and it could be mutually exclusive, or it could happen, both could happen. So in that particular scenarios, we just say, okay, if you give movie as 1 and restaurant as 2, then um, then movie and restaurant could be 3. So movie and restaurant and street vendor, obviously street vendor and restaurant are mutually exclusive. So if you have given 2 to restaurant, you'll give 5 to movie, because 3 has already been taken. So like that, we can actually give different numbers to combinations as well as single. So someone has just gone to movie and come back, you give 1. Someone has gone to movie and to a restaurant, you give him 3. 1 plus 2, 3. If someone has gone to movie and to the street vendor, so street vendor is 5, movie is 1, so 5 plus 1 is 6. So like that, you can differentiate. If I have a 6 number, then it means it has gone to both of them. So this is widely used in electronics, right? What we call this is called multiplexing. So within the 3 lines, if you want to know from which line which particular 3 line, which particular combination of lines the signal is coming, there is an algorithm called multiplexing. So if you want to categorize the values, and the values can appear both together or they are mutually exclusive, there is a process called multiplexer. So like that, you can create, it's a simple math process. You can take a look, and you can use that, you can give different values for each one of them, and then combination of those values will give you the result. There is
Got
a,
it.
okay. So like that, we have this multivariate classification. Now there comes regression. Regression means a particular number. For example, you are buying a home, or you are buying a cycle or motorcycle. Now, based on the area where you are buying, if you are buying a motorcycle within the warehouse of the distributor, the price is something. If the motorcycle is coming to your home and delivered at your home, the price is something else. If you are
Yes.
going to say a big city where a lot of motorcycles are existing and a lot of dealers are existing, the price will be something else. So the price is the usually we use regression to identify the price. For example, for Tesla, the linear regression, we use the price scenario. One of the other videos we have. So like that, what we have is regression means a particular number that is given to you. Classification means a particular category that is assigned to you. So category can be, if category is either one of them, that means you'll go to movie or you won't go to movie. 0 or 1. You only have one thing. A movie is hit, a movie is flop. So like that, if you are having, then it's called binary classification. When you have, okay, the movie has made between 0 and 50, okay, 50 crores, okay, I mean, it's a loss. If a movie is making between 50 to 100 crores, it has got its expenditure back. If the movie is making between 100 to 150 crores, you have a little bit of profit. So you can categorize different ranges, and then you can implement this algorithm. So you can have different ranges, then it becomes multivariate classification. Okay, so in multivariate classification, what we are doing is we are creating these random in a forest is basically combination of trees. Okay, so what is a tree? A decision tree is basically, given all your columns, you are putting one anchor into one column, and then you are based on the values, you are creating this tree. And the advantage of this tree is, for example, you want to say this particular node is the right, is
Yeah,
what.
but that is not a binary option, right? You have multiple options, right? There. If you traverse from the top second, so here
Hmm.
it is showing 3, right? From here you have got 3 choices, right, to make here.
Oh, you are saying this? No, I'm
Yeah.
saying, see, this particular thing represents, say, 100 to 150 crores. Okay. So I want to know 100 to 150 crores.
Gotcha.
Then by going through these nodes, you got 100 to 150 crores. Say in this particular classification, 100 to 150 crores is here. So then you have a different path here. So like that, the paths could change for a particular result to get. Remember, multivariate classification means you have categories. So if you want to choose one
Yeah,
category,
I got it.
then how there could be multiple paths. Here only two depths is there.
Correct.
So what we can do is, for example, if you take this one, the depth is more. Oh, no, depth is again 2. Let us say, yeah, this guy. Here the depth varies. Okay, so the
Yeah.
depth is going at, see, this is called level. This is 1 level, 2 level, 3rd level, 4th level.
4, 5, 6.
Right? At 6th level, there is a 2 to the power of 5 minus 1 number of nodes. Is again going into tree thing. So this is called level. Okay. One tree that is based on your column, what are the things that are happening. So you go to the left side or the right side based on the column that you have chosen. So in this multivariate classification, See, for example, this is called the depth.
Hmm.
1, 2, 3, 4, 5, 6. 6 is the depth of this particular tree. You can define how much of depth you want the trees to get generated. So here the tree is only 2 depth, 0, 1, 2, 2 depth. Here, no, where is this guy? Okay. This guy. Here, 0, 1, 2, 3, 4, 5. I don't know. The level starts with 1 or 0. I don't know. I'm not sure. So the depth is basically starting from 0 level, 0, 1, 5. So you can define in your algorithm how much depth of trees, how much level of depth you want to go. So what will happen if my depth is more? If my depth is more, we are trying to fit every data into the algorithm. When we are trying to fit every data into algorithm, then you will see a non-balanced. This is called non-balanced tree. You are trying to fit every other data having every other column. So, for example, in our CSV, there are lots of zeros here. See, usually we'll get lot of zeros in our feature columns. So if we try to fit all of them, then you will get the unbalanced tree like this one. So those things which are not useful a lot, we will not create the data.
Yeah.
So those things which don't have the particular values, we just eliminate them. If we don't eliminate them, those things that are not important, if we don't eliminate, we get unbalanced tree. This is called unbalanced. In this unbalanced tree, what you are doing, this kind of tree generation is called overfitting. When you are overfitting a particular algorithm, then let's do what is overfitting. Okay, instead of me. Say, for example, this one. Okay, you're trying to, this green line is our algorithm. Okay, when you're trying to overfit, then this is what will happen. Our algorithm is going to create the curves like this. These curves are same as our unbalanced.
Got it. Yeah.
Or this guy. So this is in balanced tree, we try to accommodate as many data points as possible. This is underfitting. When we do a lot of data points from our algorithm, then it is underfitting. If we are trying to make sure that we are trying to fit, then we are balanced.
Balanced. Yeah.
Okay. So in our
So for the same set of data, you have draw 3 lines right there, Prakash, the previous one. Yeah. So underfitting is how you that is a direct line, right? Balanced is where the balanced is what we need, right?
Balanced is what we need. That's a good algorithm. It will cover most of the cases. So the other thing is you look into this one. Underfitting, appropriate fitting, overfitting. So underfitting usually is a linear line. Linear line means straight line. Linear means straight line. A curve, like a parabolic curve, will be mostly a parabolic curve or a circle. Most of them is good fit. This one is higher order of the graph. That means you will have x to the power of 5. So if
That is overfitting is nothing but too good to be true, right? Actually, so you are trying to separate it out so perfectly, right? So that's what.
So if you see here, for example, the X value is having one Y value that is not correct, and yeah, two Y values that are correct. See, if green, assuming green is the right data that we wanted, right, classification that we wanted, then if green is the right classification that we wanted, and zeros are the wrong classification that we wanted, then this particular curve that is going from every wrong place is trying to eliminate every wrong thing, will not be able to give us good results. For example, in this X value, will I get the proper Y value? In this we got, here we got, but all these things are not there. So same here, if you see in the curve like this one, with the same X value, we have got two right values and one almost right value, right? And then we have missed a few right things.
Yeah, but that makes sense, right? You won't have 100%. So
Yeah.
if you are fitting, it means it is forcefully too good to be true, right? If you are force fitting it means.
Most of the times we may not get the right results if we force fit, overfitting. See, in this particular curve will have higher orders of X, like X to the power of 4, X to the power of 5, like that. This one, parabolic, is mostly X square. Y is equal to X square minus 4AC or something like that. A curve will always be X square. Any deviation to the curve will be higher orders of X, X to the power of 3, X to the power of 4, like that. So for example, this one is also a curve and it is going more linear. So it will be lesser orders of.
If you come perfect formula for overfitting, then that may not work for the future numbers, right?
Right.
Because
You
you
see
try
here.
to exactly map, right? Yeah.
See here, X square, X cube, X to the power of 4, and then you have some thing. Whereas if you are looking at a simple curve, then it is ax square plus bx plus c is this. So x square plus y square equals to r square is the equation of circle. 4ac, y square, x square minus 4ac is parabola. Okay, so this is overfitting. Now, when we look into the overfit, if we do overfitting, then you will see a lot of depth in our tree. So basically, to reduce the overfitting, we limit the depth of the tree to say 3 or 4 based on our results. So that is one thing. Okay. See here, yeah, this gives a very good example. The root is changing. This is one decision tree, this is another decision, it is one decision tree, this is another decision tree, this is another decision tree. So what in random forest we say is, for the same data, see, you see cherry here. Okay, for the same data, apple is there. For the same data, we are trying to create many trees, and then we do the average of the decisions to come out with the proper algorithm to implement, so that this algorithm is applied for runtime data that we
got it, Prakash.
So now basically this is where we are.
We have another 5 more minutes, Prakash.
Oh my god.
All topics are interesting. They are running super good engaging session, Prakash Garu. Yeah.
Okay, then this we can't finish now anyways.
Yeah.
So what we are doing is, I'll just give a basic thing. So what we are doing is,
and also share us the GitHub repository. This time I did not set up. Today I will find some time and I will set up. I will start working on this.
Right. This you want me to explain this and run it, or just explaining is good? Or next class we just run this?
I think next class we run. Today we have got enough sampling, right, of all these.
Okay. So basically what we are going to do is, we are saying, okay, perform random forester. Okay. Now
You need to pass the path.
path 2.
Mm-hmm.
So this is cove type is where? Cove type is d data cove type dot csv.
Mm-hmm.
So file, okay. D data.
No. That is there is no constructor with that. You have to run forester dot perform random forest and you have to pass the path here.
No, I think there should we would put something here. I believe, because what I did I changed little bit. App name, right? So that's why. Okay, super dot set app name. Get.
You need to have a variable there.
Okay, here when we are trying to get the session, we pass the app.
Hmm.
Okay, so this one will help us. You know this, right? If we don't pass anything, if it is null, null is passed here.
But then 0 is passed.
Null is passed. So
really, I didn't know.
Yeah. You can give any kind of this particular thing is basically telling us that you can give any number of values.
Null as well as comma separated array list. So it
Array
takes
list,
from
yeah.
that.
So I can say, okay, I can say
Only app name you can pass it. Random forest.
Random forest, right? So I can actually in the init, I can say app.
Yeah. Multiple. Yeah. It takes the very first one.
No, it takes all of them.
I know, but in yours, you put
In
0, right?
my, yeah, because it is 0, it goes first location and takes that. Okay, so then we do forester dot perform and then give the
CSV file.
data code data.
Okay, it's 1 o'clock, Prakash Garu. Let us.
Okay.
Yeah, we'll run this next week, Prakash Garu.
Yeah. Okay.
Okay, fine, Prakash. Yeah, thanks for the excellent session.
Thank you.
Yeah. Bye.
Bye. Let me end this.